Good evening to you all once again. Let us start our today's presentation, which is lecture number 28, and it is the continuation to our previous lecture, that is lecture number 27. There we have seen the time response of a second order system. And in yesterday's presentation, actually, we have seen the basic block diagram of a second order system. Thereby, we have seen the transfer function, that is C of S by R of S, for the second order system. Okay, let us recall the transfer function, or otherwise the standard form of, the standard form of transfer function of a second order system is given as, it is C of S by R of S is equal to, this is what we have seen, omega n square by, it is S square plus 2 times zeta omega n into S plus omega n square. This is what the standard form of transfer function of a second order system. This is what we have seen in our yesterday's presentation. Okay, this is the standard form of the transfer function of a second order control system. Okay, this is the numerator, this is the denominator. In the denominator quantity, the power of S is equal to 2, means that is the square. That is why it is called a second order system. This is called a second order system. Okay, so from this expression, if we equate the denominator part, that is what, S square plus 2 times zeta omega n into S plus omega n square equal to 0. If you equate this entire part, means denominator part equal to 0, then this particular is called as the characteristic equation. This particular equation is called characteristic equation. Characteristic equation. This equation is called characteristic equation. And also in previous presentation we have seen, depending on the value of zeta, what is the zeta? We have seen that zeta is nothing but your damping ratio, or otherwise damping factor. Depending on the zeta value, we have seen the second order system can be classified into 4 variants, 4 classifications. Means if zeta equal to 0, what is the system? If zeta is equal to 1, what could be the system? What the system can be called? And if this zeta is in between 0 and then 1, means 0 is less than, zeta is less than 1, then the what is the system then? Similarly, if zeta is greater than 1, then what is the system name? That we have already seen in our previous presentation. Now we have seen what are the roots of this equation. So for this, actually it is a characteristic equation. Normally it is a quadratic equation. Normally this is called a quadratic equation. This equation is in the order of 2, means the square. Definitely this equation will have 2 roots, means S will have 2 values, S1 and S2. Let us see what are those roots. What are those roots? Now let us see what are those roots. So from the characteristic equation, what is the characteristic equation? That is S square plus 2 times zeta omega n into s plus omega n square equal to 0. This is what our characteristic equation. From this, you find out the roots. It has two roots. Those are called as s1 comma s2 is equal to, because this is expression in terms of s and the order of the equation is 2, means s will have two values that I am calling as s1 and s2. And so to find out the roots of this expression, what is the formula? It is minus b plus or minus under square root of, it is b square minus 4 times ac by 2 times a. This is the formula to find out the roots of this expression. So here what is a? S square coefficient. So here nothing is there, means you take 1 as a. This is what a, actually s square coefficient consider as a, and s coefficient, that is 2 zeta omega n, consider this coefficient as b, and of course omega n square as c. Clear? So s square coefficient, that is 1 actually here, consider it as a, and then s coefficient, that is 2 times zeta into omega n, that consider this entire as b, and then omega n square is equal to your c. Substitute these a, b, c values in this particular expression, then what you will have actually, it is as per formula, minus is there, minus, what is b? It is 2 times zeta omega n, is it not? Plus or minus under square root of b square. What is b? 2 zeta omega n. 2 times zeta omega n square na? So you square it. Square minus 4 times, what is a? A is nothing but 1. So your 1, that is a. What is c? Omega n square. Omega n square. Whole by 2 into a. What is a? Actually it is 1. 2 into 1. Clear? 2 into 1. This further is equal to minus 2 times zeta omega n. It is plus or minus under square root of 2 zeta omega n square. You take the square to this whole. So 2 square means it is 4. Clear? Zeta square and then omega n square. Clear? Minus, it is 4 into 1, 4, means 4 omega n square. Omega n square by 2 into 1 is 2. Clear? So this is all equal to, actually it is s1 comma s2. This is all is nothing but your s1 comma s2. That's what we are finding the values basically. These are what we are finding. Now, what could be the next? Here in this under square root, so here 4 into omega n square is there, and minus 4 omega n square is there. So 4 omega n square, and then here take 4 omega n square as common in these two terms. Then how the next expression will come? Let us see that. Let us see that. What could be the next expression? This implies this is s1 comma s2 is equal to your minus 2 times zeta omega n, and then plus or minus under the square root. What you will do? 4 omega n square is there. Therefore, take 4 omega n square as common. If you take that as common, what you will have? Zeta square you will have here, and then minus 1, because 4 omega n square I am taking as common here, by 2, because 2 into 1, 2 already. Clear? Now, so it is this expression, and then what could be the next one? What could be the next expression? This equal to in further. Now, here square root of 4 into omega n square. Take this 4 omega n square outside of the root, then obviously it becomes 2 into omega n. Is it not? 2 into omega n. then means minus 2 to zeta omega n plus or minus, take this 4 outside, definitely that comes 2, omega n square becomes omega n, clear, is equal to, what is there in bracket? Simply you will have zeta square minus 1 as in bracket. It is whole by 2. And further, you can simplify that. So, this is 2 zeta omega n plus or minus this whole by 2. Now, this could also be written as minus 2 times zeta omega n by 2, this 2, because I am individually writing separately this parameter by 2 plus or minus this entire by 2, means 2 omega n into zeta square minus 1 by, clear, because these are the two parameters. So I am writing separately, then this 2 will be cancelled out, this 2 will be cancelled out. So what will remain? What is your next step? This equal to, so it is minus zeta omega n plus or minus, what is it? Omega n into square root of zeta square minus 1. This is what your S1 comma S2. S1 comma S2. So what is S1? Almost all we finished that. So what is your S1? S1 is nothing but consider plus one time, means minus zeta omega n plus omega n into zeta square minus 1. If you consider plus, then you can call it as S1. Then for S2, consider the minus. Okay, I will write here for your better understanding. I will write here. So from here, from this expression, you can consider S1 is equal to, from this, the next step. Okay, S1 is nothing but minus zeta times omega n. Consider plus here, because plus or minus, no, consider plus first. Omega n into, it is zeta square minus 1. That is what your S1. Similarly, what is your S2? S2 is equal to minus zeta omega n minus omega n into your zeta square minus 1. These are what your two roots. These are what your two roots of that given characteristic equation. Clear? These two are the two roots of your characteristic equation. Okay, no problem. Now, collectively, just you consider this one, that is S1 comma S2 is equal to, consider this one, it is minus zeta omega n plus or minus omega n into square root of, it is zeta square minus 1. Let us consider this expression as it is. Now you can apply various values of zeta in these roots. These are what the roots, no? Roots of characteristic equation. S1 comma S2 is equal to, this one is the, this indicates the roots of that characteristic equation. Now, case 1. Now you can call it as case 1. What is case 1? For zeta is equal to 0. If zeta equal to 0, what is zeta equal to 0? So, if zeta equal to 0, the system is called as undamped system. The system is called as undamped system. So, for undamped system, what are the roots of that characteristic equation? So, substitute zeta equal to 0 in these roots, then obviously your S1 comma S2 is equal to, substitute this zeta equal to 0 here. So, means obviously zeta into 0 means your term this becomes 0, the first one, and plus or minus, okay, into omega n into square root of, what is zeta? It is 0, it is minus 1. Clear? So this implies actually plus or minus omega n into 0 minus 1, it is minus 1. Clear? So what is minus 1? Remember that from your complex analysis, complex theory, so you know that j square is equal to some j into j in complex theory. j into j is equal to j square, and that value is minus 1 actually. J square value is minus 1 in complex analysis. Okay, if you see the complex numbers or complex analysis, there you can see that j square is equal to minus 1. Then j is equal to what? Square root of minus 1. Clear? J square is equal to minus 1, then j becomes square root of minus 1. Therefore, from here, from this definition, plus or minus, you can write omega n into what is root of minus 1 can be written as j. Is it not? So means your S1, S2, S1 comma S2 is equal to plus or minus j into omega n. Okay, j into omega n. What is this actually? What are this actually? Means S1 is equal to take plus. Okay, for S1 consider plus value, means plus j omega n. Is it not? Consider plus 1 means plus j omega n. Similarly for S2 consider the minus 1, that is minus j omega n. Okay, one root is plus j omega n and the second root is minus j omega n. Clear? This means this equal to, okay, clear now. So S1 is equal to plus j omega n and it is minus j omega n, the second one. This is what your S1, this is what your S2. Two roots. So if you observe these two, what you can say from here? The roots are purely imaginary. The roots are purely imaginary. Therefore, for undamped system, from this what you can conclude that for undamped system, the roots are purely imaginary. That is what the condition. That's what the condition. For undamped, you can write that. Okay, for undamped system, the roots are purely imaginary. The roots of the given system for undamped system are purely imaginary. Remember that. That is very important. Now, this is first case actually. That is case 1. Now, see the case 2. What is case 2? The second possibility. Case 2. For zeta equal to 1. What is for zeta equal to 1? What we can call the system? It is critically damped. For zeta is equal to 1, the system is called, critically damped. Okay, the system is called critically damped system. You have to note down this. Critically damped system. Okay, so means for critically damped system, what are the roots? Substitute zeta is equal to 1 in this given roots. Means if you substitute zeta 1 value in the given above roots equation, S1, S2, S1 comma S2 is equal to, zeta is equal to 1, means it is minus omega n. Clear? Because zeta value becomes 1. If you substitute 1 here, it becomes 1 minus into omega n plus or minus. Clear? Again omega n under square root of, it is zeta square means 1 square minus 1. So 1 square is 1 minus 1 0, therefore 0 into something 0 you will have minus omega n. So your S1 comma S2 both are same roots actually, because this part becomes 0, only minus omega n you will have. Okay, means that what? S1 is equal to minus omega n, S2 is also minus omega n, means the roots are equal. You can say not only that, real part, this is the real, this part is called real part, this is called imaginary part basically. Let us say, because if j is there, okay, otherwise you can say that simply as far as this concerned, this becomes 0, only you will remains here. This part becomes 0 definitely, because 1 minus 1 is 0, 0 into something 0, this everything will becomes 0, then only you will have minus omega n. Means your S1 is minus omega n and S2 is also minus omega n. Both roots are equal, and therefore this is called the roots are real and equal. The roots are real and then equal for zeta is equal to 1. Therefore, if the system is critically damped, then your roots will be real and equal. Both roots are equal. Okay, that is another important condition you should remember. Okay, then let us see the third case. Let us see the third case. What is the third case? The third case is case number 3. Case number 3, that is 0 is less than zeta is less than 1. What is this system? If zeta is in this 0 to 1, then it is called underdamped. What is that? Underdamped. It is underdamped system. This is called underdamped system. Most of the time we will consider this condition only. Okay, we will imagine our system is underdamped system. Then we will study its behavior, its characteristic. Okay, for this under this condition only. This condition is very, very important. So if zeta lies in between 0 and then 1, then that is called underdamped system. Underdamped system. Okay, for this underdamped system, what will be the roots? What will be the values of S1 and S2? Then substitute S1 comma S2 is equal to, so for you write as it is that equation, minus zeta omega n plus or minus omega n into square root of zeta square minus 1, you write as it is. And now as our condition is zeta is less than 1, so for this condition we will do a small adjustment here, means modification. Minus zeta omega n, let it be here, plus or minus omega n be like that. And here what I will do in bracket, no, I will take minus 1 as common here. I will take minus 1 as common here. Then you will have minus 1. If you take minus 1 common, then 1 will be comes first. Then minus zeta square you can write. Clear? Am I clear? If you take in zeta square minus 1, in this from this you take minus 1 as common. If you take minus 1 as common, if you put bracket here, then obviously 1 will be come here, then minus zeta square, and then you multiply with minus 1 to in bracket, minus 1 into 1 minus 1, so minus 1 is okay, then minus of minus plus 1 into zeta square, so this entire equal to this also. Therefore you can do small adjustment here like this, and from here what I can write, minus zeta omega n plus or minus, so this is omega n. Okay, this can be written as minus root of minus 1 and then root of 1 minus zeta square. Can I write like this? Can I write like this? Okay, just as it is I am writing in the next second subsequent step, minus zeta omega n plus or minus omega n, just I have mentioned the same as it is. Here square root of, in this total square, just I am writing very clearly root of minus 1 into root of the second term. So here, why? Because zeta omega n plus or minus, it is root of minus 1 can be written as j. From this root of minus 1 is nothing but your j. You can write j times omega n, j times omega n into square root of 1 minus zeta square. Okay, omega n square root of 1 minus zeta square. This is what your S1 comma S2. Okay, and here you can write that this part omega n into square root of 1 minus zeta square, this part we can treat it as omega d. You can treat as omega d. I will write here. So I will erase here. I will erase. You are following, no? So just I will erase here and I will write the next step. So it is S1 comma S2 is equal to, it is minus zeta times omega n, means the next step I am writing here, it is plus or minus. So omega n j times omega n into square root of 1 minus zeta square is called as, okay, omega d. Omega d you can write. So here omega d is equal to, what is omega d? Omega n into square root of 1 minus zeta square. This is what I am calling as omega d. This is what, this omega d is nothing but this one. Clear? So from here, omega n into square root of 1 minus zeta square, this entire part I am calling as omega d. Just I mentioned here. This omega d is called as, okay, damped natural frequency. This is called damped natural frequency. In the beginning of this presentation of previous in session, we have seen that what is omega n? This is omega d, this is omega n. What is omega n? Omega n is nothing but undamped natural frequency. Remember that. Okay, omega n is nothing but undamped natural frequency, whereas omega d is called as damped natural frequency. Omega d is called as damped natural frequency, and the relation between damped frequency and an undamped frequency is this. This is what the relation between, this is very, very important. This relation is very, very important. The relation between damped and then undamped frequency, undamped is equal to damped into square root of 1 minus zeta square. You will expect questions in your competitive examinations based on this. I will solve these in subsequent also. You will understand better there. So right now, remember that this is the basic relation between damped natural frequency to the undamped natural frequency. Now if you can see that, so what you can conclude on the roots for this system, for underdamped system? So your roots are becomes what? It is called as some complex conjugate roots. You will have complex conjugate roots. This is called as complex conjugate, because so one time plus is there, real part, imaginary part, next is the minus is there. So this is involves complex. This is called complex conjugates. So the roots are complex conjugates for this underdamped system. Now the fourth category means class 4, means case 4, otherwise you can say. What is your case 4? What is your case 4? Obviously for zeta is greater than or equal to 1. Zeta is greater than or equal to 1. What is this? If zeta is greater than 1, what is this system is called? Overdamped. What? Overdamped system. It is called overdamped system. So for zeta is greater than 1, what we can say? You write as it is same expression, means s1 comma s2 is equal to minus zeta omega n plus or minus omega n into square root of zeta square minus 1. As it is, we will consider the same expression, because as zeta is greater than 1, so there is nothing, you write same as it is expression. From this, what you can conclude? The roots are real but unequal. The roots are real because there is no imaginary term here. There is no j term here. No. So here means s1 is equal to what? Minus zeta omega n plus omega n into zeta square minus 1. For s1, you consider the plus sign, okay, first, and for s2, consider minus the next. Means, so if you consider plus, some one value will come. That is definitely real value and some value will be there. And if you consider the second time the minus, definitely it also some real value, definitely not imaginary, it has some value, means values are real but not equal. Therefore, under for this category, for overdamped system, the roots are real but unequal. So these are the important classification based on the damping values, damped I mean, okay, damping factor or damping ratio. So depending on the values of this damping ratio or damping factor, the roots can be classified like that. So when the imaginary roots will come, when complex conjugates will come, the roots, and when roots are real and not equal, like that. So you have to, as a in this manner, you please go through it, and you can practice it. It definitely will remember very easily. So I think with this I will close today's presentation. In the subsequent presentation, we will see the response of a second order system with zeta equal to 0. So in second order system, normally we can see, so we will take the transfer function of a system. Okay, then we apply the step input, because our standard inputs are step input. I mean unit step, otherwise unit step signal, unit ramp signal, unit parabolic signal. So by assuming these are the input signals, and also we have to imagine that what is the value of zeta. So the second order system is completely depends, and it will be defined for zeta value itself. Zeta is very important. The value of zeta plays very important role in the second order system. Therefore, in the next presentation, we will see the response of a second order system for a unit step input with zeta equal to 0, and then zeta is equal to 0 less than zeta less than 1, like that, under damped system. And likewise, as we have seen these 4 cases, the same cases will be applied there, and we can see what could be the output, how the system responds, and like that. We have to see all these in the next subsequent presentation. I hope that you have enjoyed this presentation, and definitely if you like this, and don't forget to like, and then definitely you comment, you suggest, and even I request you to subscribe to this channel for the updates, and never and don't forget to share these valuable information to your friends and wherever they are, because today the media and everything, we have very quick access, and we can connect the people through this. Therefore, I request you to be connected each other, and share to as many as your friends, so that everybody will be get fully acquainted with the subject, with the very basic concepts of this. Thereby you will excel. Okay, thank you one and all.